Good morning to all. M. Salakshi, Department of Electrical and Electronics Engineering in Tandai Periyar Government Institute of Technology, Vellore. Welcome to e-learning class. Today we are going to see inductance, capacitance, solenoid and toroid. Basic of inductance is a ratio of total flux linkage to the current produced in the flux, or a current can be generated in a conductor by changing magnetic field, which is proportional to rate of change of magnetic field, denoted as L, and unit for inductance is Henry, which is denoted by a symbol capital H. So the formula is L equal to N by phi. So total flux linkage N phi by current produced in the flux. Also, it is used as an energy storage device in SMPS to produce DC current. Also, which supplies the energy to the circuit to keep current flowing during off switching periods. Inductance of solenoid. So solenoid is coil insulated or enabled wire wound on a rod shaped form made of solid iron. So considering the solenoid having number of turns per unit length, when the current passing through the solenoid, magnetic field is produced inside the solenoid, which is directed along the axis of the solenoid. So it is tightly wounded on a cylindrical core of a wire. So cylindrical core of a wire, this is called as a solenoid. Considering the solenoid of length L, area of cross section A, number of turns N, magnetic field can be carrying a current is given by B equal to mu Ni, number of turns with current carrying N. N equal to capital N by I, L, length. So N number of turns. So let flux be the magnetic flux linkage through each turn of the solenoid. So we are going to calculate the total flux N phi suffix B in magnetic field. So we know the formula of N into L, flux BA. So substitute the values here for magnetic field and flux and number of turns. Be calculating the inductance. So inductance is defined as the ratio of flux linkage to the current carrying. So substitute all the values, equation 1, 2 here, and we'll obtain the formula to calculate the inductance of solenoid, okay, per unit length. So per unit length L by small I, okay, mu naught N square A. So A is an area of cross section. Also it depends on number of turns per unit length and area of cross section A. Next is an inductance of toroid. It is actually a coil insulated, or we can say it is in a wire wound on a donut shape. Just imagine. So toroidal transformer having both primary and secondary inductive winding, which is used to step up or step down the input voltage applied to the primary winding. The dotted lines represents the current. Dashed lines is number of loop times the current in each loop. So considering the ring with the number of turns N, the current flowing is capital I. So from this, flux density inside the toroidal ring is B equal to mu Ni by 2 pi R. So total flux linkage is N phi. Phi equal to B into A. Phi equal to N. We know phi equal to BA. So substituting the flux value and also the magnetic field formula, mu Ni by 2 pi R into A. So after calculating, cancelling all the common terms, will be obtaining the inductance of toroid. So here area is of a circle. with inner and outer radius with an height of the toroid r1 and r2. So if it apply the limit, will be obtaining n square mu h height of the toroid by 2 pi into ln r2 by r1. H represents the unit of inductance Henry. Next, in inductance in coaxial cable. So inner radius is A and outer radius is B. Current through the coaxial cable will be B. So from this we are going to find the magnetic field and also the magnetic flux with a limit A to B. Here we are going to consider the cylindrical system. Cylindrical system, it represents like this. So from this we are going to find, generally this is a coordinate systems. So X, Y, Z, this is a coordinate system. So we are assuming this as a cylindrical. So cylindrical, the representations are R, phi and Z. So these are the terms to calculate in cylindrical form. For spherical r phi theta, for coordinate x y z. So that is the main difference. So from this we are applying the limit z from 0 to d. Our radius is both, we are having inner and outer radius, so a to b. So this is a formula for dA means b, and this is ds. So b dot ds. Here ds we are representing in cylindrical form. So dr, d phi, dz. Just applying the limit, upper minus lower limit for z. Just differentiating the z terms. D will be obtained, and here 1 by r ln r, upper minus lower limit, so ln b by a. This is the formula to calculate only the flux linkage of a coaxial cable. To calculate the inductance of coaxial cable, inductance equal to total flux linkage by total current. So from this, just apply the total flux linkage formula obtained in previous equation and cancel the common terms. Be obtaining L equal to mu by 2 pi ln B by A in terms of Henry. If we are going to calculate per unit length, L by D, okay, that is the unit length. So L by D will be equal to mu by 2 pi ln B by A Henry per meter, because we are going to calculate inductance per meter. Next is a mutual inductance is between the two coils. The property of the coil is 2, which it opposing the change of current in other coil or neighboring coil. When the current in neighboring coil changes, the flux sets up in the coil, and because of this, changing flux in coil is called as mutually induced EMF or mutual inductance. So from the circuit, this is your primary side, V1, I1 current, inductance L1 flowing with a number of turns, phi 11, it is flowing in this direction, so phi 11. Similarly in secondary L2 I2 phi 22, only this turns. If the mutual links with phi 1 to 2, so in this direction it represents phi 1 2. If it links with 2 to 1, the direction will be phi to 1, opposite direction. So two conditions, coil 1 and coil 2. So same, N1 turns with L1 carry current I1. So flux produced will be phi 11. Similarly for N2, phi 22. If the flux produced in link 1 with 2, phi 12. Similarly, flux producing in 2 links with 1, phi 21. So this is the condition. Mutual inductance between these two coils are the ratio of flux linkage. So ratio of flux linkage is nothing but N phi to the current on other coil. If we are taking this as an phi 12, the equation for this will be N2, output side is N2, to the other coil means opposite current, so I1. Similarly to 1 means here the output is 1, so N1 phi 21, opposite current means other coil is I2. H represents the unit Henry. Also it depends on the magnetic interaction between the two currents. So it is same as self-inductance, means the unit is same, Henry. There is a two condition for mutual inductance. If two coils are connected in parallel leading, effective inductance will be L1 L2 minus M square by L1 plus L2 minus 2M. Similarly, it is in parallel opposition, L effective will be equal to L1 L2 minus M square by L1 plus L2 plus 2M. So the main difference for aiding and opposition is plus and minus. So this is the formula to calculate the mutual inductance whether the two coils in parallel aiding or in opposition. Thank you.